Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on using matrices to solve systems of equations with 2 or 3 variables. In our last lesson, you learned how to turn a system of linear equations into an augmented matrix. You also learned that in order to solve a system of equations, you must change it into an equivalent system by performing one of the 3 operations: swapping, rescaling, or pivoting. Students, in today's lesson, we will study how to perform these operations. Are you ready to begin? Before we look at an example, let us define the notations that we will use to represent swapping, rescaling, and pivoting. Swapping of a first and second row will be denoted by R1 switches with R2. Rescaling a third row by a non-zero number, small r, will be denoted by R3 becomes small r times R3. Pivoting of the second row by r times the first row will be denoted by R2 becomes R2 plus small r times R1. Okay, students, let us solve this system of equations. X minus 2y plus z equals 7. 3x plus y minus z equals 2. 2x plus 3y plus 2z equals 7. Our first step is to write out the augmented matrix. In our first row, we have 1, -2, 1, and 7. In our second row, we have 3, 1, -1, and 2. Our third row is 2, 3, 2, and 7. In order to solve this matrix, our objective is to get as many zeros as possible in the coefficient values. We can pivot the second row and turn the 3 into a 0 by multiplying the first row by -3 and adding the rows together. Make sure that you change all the elements in row 2. For example, the -2 in row 1, when multiplied by -3, becomes 6 and is added to the 1 in row 2. This gives us 7. Can you see where we can make another 0? What about the first value of 2 in the third row? We can pivot the third row by multiplying the first row by -2 and adding the rows together. This pivot gives us 2 zeros in the third row. This is because the second value of 1 in the top row is multiplied by -2 and added to the second value of 2 in the bottom row. This gives us another 0. Now that we have 2 zeros in our third row, we can solve the equations. Our last matrix corresponds to this system of equations. X minus 2y plus z equals 7. 7y minus 4z equals -19. 7y equals -7. Students, please take out a piece of paper and solve this system of equations. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to solve the equations? If you answered that x equals 2, y equals -1, and z equals 3, you are correct. Well done, students. The easiest way to solve this example is to first solve for y using the equation 7y equals -7, and then substitute this value back into the other equations. If you had difficulty with this activity, please ask teacher to review your work after the lesson. Students, there are several definitions that are useful for you to know. The first is the phrase row echelon form. A matrix is considered to be in row echelon form if any of the following statements are true. If there is a 0 row, it comes at the bottom. The first non-zero element in each non-zero row is 1. The number of zeros preceding the first non-zero element in each non-zero row, except the first row, is greater than the number of such zeros in the preceding row. Our next definition is row reduced echelon form. A matrix is in row reduced echelon form if and only if the following statements are true. It is in echelon form. The first non-zero element in each non-zero row is the only non-zero element in its column. Students, please copy down these examples and determine which of the matrices are in echelon form. Are there any that are in row reduced echelon form? Please begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us look at each matrix together. Matrix A is in echelon form because its 0 row is on the bottom. Matrix B is not in echelon form because the first row has 2 zeros, which is a greater number of zeros than are found in row 2. Matrix C is not in echelon form because only one row has a 0. Matrix D is not in echelon form because the 0 row is in the middle, not the bottom. Finally, none of the matrices fits the requirements for row-reduced echelon form. There are many more examples of matrices in your textbook, students. Please review each exercise and work through the solutions to make sure that you understand these concepts. As practice, after the lesson, try to transform matrix B and matrix C from the activity into their row echelon forms. Students, we have covered a lot of material today. You have learned how to perform the 3 elementary operations on matrices. You now know how to swap, rescale, or pivot rows in a matrix in order to find equivalent equations. You have also learned to define the echelon form and the row-reduced echelon form of a matrix. Now you can solve systems of equations in 2 or 3 variables by using these elementary operations. That is all the time we have for today. Until our next lesson, thank you, teacher. Thank you, students.